All right, ladies and gentlemen, we're looking at 5.3 bisectors of a triangle. Okay, this is specifically, this section is talking about angle bisectors, but we're going to review perpendicular and angle bisectors just so we get it. Ready? Perpendicular bisector of a triangle is a line or ray or segment that is perpendicular to the sides of the triangle at the midpoint. I like to draw a picture each time so we can remember what they are. So we've got a triangle. We know if we draw one perpendicular bisector, makes it a 90-degree angle. It cuts it in half at its midpoint. And we also know the two sides are equal to each other. Okay? When three or more lines or rays or segments intersect in the same point, they are called concurrent lines. The point of intersection of a concurrent line is called the point of concurrency. So, first we've got mid-segments. They don't have a point of concurrency. Now we've got perpendicular bisectors. They have a point of concurrency. If we have three of them, they meet in the middle. And then angle bisectors will have a point of concurrency. So this is a new word, point of concurrency. We've got to remember it. Okay. Angle bisector of a triangle is a bisector of an angle of the triangle. The point of concurrency of the angle bisector is called the intercenter. Okay, so let's make a triangle for angle bisectors. What does bisector mean again? It cuts it in half, so we cut our angle in half. Okay? And if we have three of them, so I'm going to draw three. Right there, our point of concurrency is called an intercenter. Okay, let's talk about what is special about these things. Okay, so we've got the angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. Okay. So if a point is on the bisector of an angle, it is the same distance from the angle. Converse of angle bisector, if a point is in the interior of an angle and is equidistant from the sides of the angle, then it lies in the angle bisector. The angle bisector of a triangle intersects at a point that is equidistant from the sides of a triangle. Okay? So if we're looking at angle bisectors are in a center, we cut all of these in half. This point right here where it meets, all of the lines are equidistant from the sides. That means these lines here are all the same length. So a perpendicular bisector, the circumcenter for the point of concurrency for perpendicular bisectors, they're all equidistant from the vertices. The intercenter is all equidistant from the sides. So I just used a whole bunch of words there. Should we write something on the board so we remember? We've got all of our steps up here for stuff that we do with mid-segments. Let's put some stuff up here with perpendicular bisectors and angle bisectors. So, perpendicular bisector goes with its point of concurrency is the circumcenter. I spell that right? Mm-hmm. Okay. And it is equal distance from vertices. And I'm going to draw a little picture. Okay, this point right here is equal distance to all the vertices. Okay, now we've got angle bisector. Its point of concurrency is called the intercenter. Center. Okay, it is equal distance from sides. from the sides. So now I'm drawing a little picture. Cuts all my angles in half. Okay? It is equal distance to all the sides. Okay. Highly recommend you write these things down. All right. Now we're going to try some problems using this information. All right. First, we're going to look at perpendicular bisectors again. This should be reviewed from yesterday. All right. We've got triangle A, B, C with perpendicular bisectors ED, A, G, F, and B, G. Okay. We know that A to B is 22. Oops. A to B is 22. And we know A to D is 14. So let's answer these questions. What is the distance from D to B? 14. Okay, and I'm going to make a little mark on here to explain this. AD, DB, and DC are all congruent to each other because it's a perpendicular bisector. Okay. Okay, to make sure we don't think that's 141. All right, A to E. What do we know about perpendicular bisectors? It cuts it in half. 11. Okay. I'm going to pause for a second, and I want you to try example 2 on your own, and I'm going to walk around and you can ask questions. So I'm going to pause this for a second. All right. So I saw most people get this 100%. A few people made little mistakes because they forgot some of the rules. Okay. We know O to P is 20 because we know S cuts it in half. 10 and 10 is 20. R to P, O to R, and Q to R are all the same length. So these should all be 12. T to P, we know Q to P is 22. What's half of 22? 11. Some of you guys put 10 because you think all the ones on the outside have to be the same. It doesn't. It's not an equilateral triangle. Let's turn it over and look at some angle bisectors. Okay. We've got triangle. Shh. You don't need to keep saying what. I'll tell you the answer. Okay, A, B, C, D, E, F, G. Okay, we know D to E is 17. No, we don't. We don't now because I gave you the answer. D to C is 28. F to D is 17. And that's all we know. We know the distance between D and E is 17 because the rules with angle bisectors is the distance from the side to the middle are all the same. So those will all be the same length. Okay? How do we find BD? Do we know what the answer is? Yes?
When you go back to using the perpendicular bisector.
But it's not a perpendicular. Is it a perpendicular bisector? Or is it an angle bisector? Because in my instructions it says it's an angle bisector. I know there are 90-degree angles right there, but they're not supposed to be there. We don't know. How do we find G to D? That's also 17. Okay. And D to A? We don't know. Because we don't know they're perpendicular bisectors. Okay. Let's go.
Wait, which one is that question mark with?
D. This should be D. Do you guys have D on your paper?
Yeah.
Yeah, this is D. B and D, you don't know. Okay. Let's move on to the next one. We've got A, B, C. This is P, Q, R. All right. P to R is 3. We know that P to C is 5. And we are using our angle bisectors. What is BP? Do we know? What is it? We don't. Do we know P to Q? What is it? 3. Do we know Q to C? Do you see that it says it's a right angle? And we're given that this is 5. We know this distance right here is 3. So how would we find that distance right there? Now add them together. It's a right triangle. We've got the hypotenuse and the side. What is that funky thing called?
Your leg. No.
Not hypotenuse legs. We're not proving two are congruent. We're finding an unknown leg of a right triangle. Pythagorean theorem. 3 squared plus my unknown squared equals 5 squared. So 9 plus my unknown squared equals 25. Subtract. We get my unknown squared equals 16. So QZ equals 4. Because the square root of 16 is 4. And that's it. All right, I am going to read to you now, so get out a piece of paper. I'm trying to give you time to start your homework, so I want to read to you quickly.